Welcome back to our YouTube channel. If you are watching this channel for the first time, do well to turn on your notification bell, subscribe, like, comment, and share. Today we'll be looking at the concept of chemical equilibrium. I've come to realize that many students find it difficult to answer questions correctly on this topic. And this is because many students do not understand this concept very well. When you talk about chemical equilibrium, we are talking about a chemical reaction that is maintaining equilibrium. What does this mean? It means a chemical reaction in which the rate of forward reaction is equal to the rate of backward reaction. That means that this reaction is going to be having two sides, the forward reaction and the backward reaction. And the same is maintaining equilibrium because the rate of forward reaction is equal to the rate of backward reaction. Now, when we talk about this system maintains its equilibrium even though factors that affect chemical equilibrium are imposed on this reaction. And that is the peculiarity of this reaction that is maintaining what? Chemical equilibrium. The peculiarity is how does this system maintain equilibrium even though these factors are being imposed on it. We want to look at question on this concept and explain how does this system maintain its equilibrium even though these factors are imposed on it. This question that I want to look at is talking about the effect of temperature on this system and how does this system maintain its equilibrium. To answer this question, we have to first look at this delta H. This delta H is positive. It means that the system is operating under endothermic condition. And as I have explained earlier, that this system is going to have two sides, the forward reaction and the backward reaction. So let's interpret this question. Since the delta H is positive, it means that the forward reaction is endothermic and the backward reaction is exothermic. That is the interpretation with this delta H. The forward reaction is endothermic and the backward reaction is exothermic. Now, if you increase the temperature of this system, how does this system still maintain its equilibrium? Firstly, if you increase the temperature of this system, note that the increase in temperature is going to go and affect the endothermic side. Increase in temperature will go and affect always the endothermic side. And since we say that the forward reaction is endothermic, that means that increase in temperature is going to go and affect the endothermic side. Now, how does this system still maintain its equilibrium? This system is going to shift its equilibrium position towards the endothermic side, in which the increase in temperature is going to affect, so that it can remove the effect of that increase in temperature. So what will happen? If you increase the temperature of this system, what will happen? The equilibrium position is going to shift forward. That means that our answer will be A. It will be A. It means that the forward reaction is going to be favored. It will favor the forward reaction because the equilibrium position is going to shift towards the forward reaction, which is the endothermic side, which increase in temperature has got to affect, so that the effect of increased temperature can be removed. That's that. Let's come to the second question. This second question, let's look at our delta H. Delta H is negative. If our delta H is negative, and I say that this system will only have two sides, the forward reaction and the backward reaction. If delta H is negative, it means our forward reaction is exothermic and our backward reaction is endothermic. Let's come to our question. In the reaction above, the concentration of SO3 can be increased by. This question means that what will cause equilibrium position to shift towards the production of SO3. And since we said that the forward reaction is exothermic, note that increase in temperature will affect the endothermic side, and decrease in temperature will affect the exothermic side. Since the forward reaction is exothermic, it means that it is decrease in temperature that will affect this side that is exothermic, with the forward reaction, which is the reaction that is leading to production of SO3. That means that the production of SO3 can be increased when you decrease the temperature. Alright, let's come to the concept of pressure, how pressure affects a chemical system in equilibrium. Let's look at this question. What will be the effect of decrease in pressure on the following equilibrium system? There is a relationship between pressure and volume of a gas. So for us to know the effect of pressure on an equilibrium system, what we are going to do is calculate what is the total number of volume on the reactant side to the total number of volume on the product side. And how do we get that? We have to first calculate what is the total number of mole on the other side. According to Avogadro's law, your number of mole is equal to the number of volume. So here we have 1 mole plus 3 mole. We have 4 mole, which is also equal to 4 volume. Here we have 2 moles. 2 here is proportional to what? To volume. Now, according to Boyle's law, decrease in pressure is inversely proportional to increase in volume, while increase in pressure is inversely proportional to decrease in volume, because pressure and volume are inversely proportional. So decrease in pressure is going to go and affect the side that has higher volume, and the side that has the higher volume is the backward reaction, which is the reactant side. So decrease in pressure is going to go and affect this backward reaction. Now, how does this system maintain equilibrium? This system is going to shift its equilibrium towards the backward reaction, which decrease in pressure has gone to what? To affect. So I can remove the effect of that decrease in pressure. So what will be our answer here is that the reverse reaction will be favored. Our answer is C. Let's come to the concept of increase in pressure. Let's look at if we increase the pressure of a chemical system in equilibrium. How does the system maintain its equilibrium? Let's look at the question. What is the effect of increase in pressure on the following equilibrium system? We are still using the same example. Here we have 4 volume and we have 2 volume. And we know that pressure is inversely proportional to volume. Whenever you increase the pressure of a system, the volume is going to decrease. So increase in pressure is going to affect the side that have lower volume. The side that have lower volume is the forward reaction. So increase in pressure is going to affect the forward reaction. How does the system maintain equilibrium? The system is going to shift its equilibrium towards the forward reaction, so I can remove the effect of the increase in pressure. So what will be our answer? The answer is what? The forward reaction will be favored. Let's now solve a question that talks about both the effect of temperature and pressure on the chemical system in equilibrium. Let's look at this question. A certain industrial process is represented by the chemical equation. Which of the following conditions will favor the yield of the products? Now let's first pick that of temperature. To know about the effect of temperature on a chemical system in equilibrium, we have to look at our delta H. Our delta H is positive. That means that this system is taking place under endothermic condition. And since our reaction will always have 2 sides, then we have to interpret the equation based on that 2 sides. If our delta H is positive, our delta H always symbolizes the forward reaction, and since it's endothermic, that means that our forward reaction is endothermic, and that means that our backward reaction will be opposite. Our backward reaction will be what? Exothermic. Never forget that I said that increase in temperature will always affect the endothermic side. And our question is, which condition will favor the yield of the product? Our product is our forward reaction. The reactant giving us product. And we have said that forward reaction is endothermic. Alright, what will affect is now increase in temperature. Let's talk about the effect of pressure on this system. We have said that pressure only affects gaseous molecule of species of any chemical reaction. Pressure only affects what? Gaseous molecule. So that means that before we can know the effect of pressure on this system, we must be able to calculate the total number of volume on the reactant side to the total number of volume on the product side, which is the forward reaction and the backward reaction. And to calculate the total number of volume, First thing, we have to calculate the number of mole. And according to Avogadro's law, our number of mole is equal to the number of volume. So here we have 2 mole plus 1 mole, we have 3 mole, which is equal to 3 volume. Here we have 1 mole plus 3 mole, that is 4 moles, which is equal to 4 volume. Alright, how does pressure affect this system? That is explained by Boyle's law. Pressure is inversely proportional to volume. So here we have higher volume, here we have lower volume. That means that it is decrease in pressure that will affect this side, because this side of the product is having higher volume. If it's having higher volume, pressure is inversely proportional to volume. That means that decrease in pressure will affect this side. So our answer will be decrease in pressure. Also, if pressure will affect any chemical system in equilibrium, at least one of the species of the reactant must be gaseous and one of the species of the product must be gaseous. If that does not happen, there is no way we are going to calculate the number of volume and how we are going to compare it. Also, the total number of volume must not be the same, because if they are the same, we will not be able to compare which side is having higher volume and which side is having lower volume, and we will not be able to know which side will increase in pressure will affect or decrease in pressure will affect. So for this question, our answer will be what? Our answer will be A, increase in temperature and decrease in pressure. Let's come to the concept of concentration and let's look at this question. We have in the reaction E plus F giving us G plus H. The backward reaction is favored if the concentration of, we must look at the answer. First thing, if the backward reaction will be favored in this question, 2 conditions must be in place. Now, the condition is that the concentration of the product, which G plus H, must be increased. If you increase the concentration of the product, first know that this reaction is already in equilibrium now. So if you increase the concentration of the product, that means that the product will be greater than the reactant. And for balance to be maintained, that means that some concentration have to be released from the product side to the reactant side, and that will make the equilibrium to shift from right to left. Do you understand? The equilibrium will go to what? Shift backward, so that some concentration will be released back to the what? To the reactant side, so that there can be what? Balance. Another condition that will cause the equilibrium position to shift backward is when you remove some concentration from the reactant side. You know the reaction is already balanced now. If you remove some concentration from the reactant side, that means that the product side is going to be greater than the reactant side. So for balance to still be maintained, some concentration has to be released from the product side to the reactant side, so that the balance can be maintained. Now looking at this option, what can we pick? What you can pick is that is option B. E is reduced, because E is one of the reactants. So if you remove E, if it is what? A part of the reactant, the reaction will look unbalanced. So for it to be balanced, some concentration have to come back from the product side to the reactant side, so that there can be balance. So E is reduced. If you reduce E, the equilibrium will shift backward, so that some concentration can come back to the reactant side and there will be balance. Let's come to the second question. In the reaction M plus N giving us P, the first reaction is favored if the condition of, let's look at what will be the answer. If the reaction is going to shift forward, if the equilibrium position is going to shift forward, 2 things are also the condition. First thing, if you increase the condition of the reactant, you know the reaction is already in the equilibrium now. If you increase any of these reactants, that means that the condition of the reactants will be greater than that of the product. So for balance to be maintained, condition has to shift from the reactant side to the product side. Some have to shift from the reactant side to the product side, so that they can be balanced. Another thing that can also cause the equilibrium position to shift forward is when you reduce some condition of the product. You know, if you remove some condition of the product, the reactant side also is going to be greater than the product side. So for balance to still be maintained, condition has to be released from the reactant side back to the product side, so that some of the conditions that we remove from the product side can be replaced and there will be balance. So for us to pick our answer our answer now. What will be our answer? It's very obvious that our answer was M is increased, because M is one of our reactants. So if you increase the coefficient of M, no, there will be no balance again. The coefficient of the reactants is greater than that of the product, so some coefficient has to shift from the reactant side to the product side, and that will make the non-coefficient to shift forward to this coefficient back to the product side, so that they can be balanced. So our answer was M is increased. This side, E is reduced. I believe that we have gotten the concept very well. Also, we have some part of this chemical equilibrium that we have not touched, like how does temperature affect equilibrium constant. Though pressure does not affect equilibrium constant, and pressure does not affect equilibrium constant. Also, we have not talked about how to write equilibrium constant of any chemical system in equilibrium. If they give you any chemical system in equilibrium, they may ask you to write the equilibrium constant of that chemical system in equilibrium. Also, we have the aspect of calculating the equilibrium constant of a chemical system in equilibrium. We have not also touched that area. We are going to touch that in our next video. So watch out for our next video.